Okay. Who has questions and who wants me to summarize the project?
Hocam, if you can explain step by step, that will be great. Because Bertoji, I guess, sometimes just give some extra information about the lecture. So.
Okay. Then I'll make a short summary. Okay, I'll give you a short summary about the project. Don't worry. But before that, I'd like to take questions if your friend says like small questions, because I want to answer them so they can leave if they know if they understood the project. I don't want to keep them for so long. So I'll make the summary after I answer the questions, if anybody has the question. Do you have any questions?
Hocam, should we include SSP tables into the report? For example, we found, for example, log normal is best choice. So should we show
Yes, you should put the table. I mean, I should see how did you decide what is the best distribution method.
Okay. Okay.
Hujam, are we supposed like to upload all the methods or just the one that fits?
One method. You'll apply one method only. You'll decide which method is best for your data, then you'll apply that method only.
Yeah, and I will upload the one that fits, right?
Can you say it again?
Upload it like in my report.
Yeah.
And upload the one that fits best, right?
Yes.
Okay. Okay.
So I think everybody is here for a summary, I guess, since you don't ask any questions. Then let me give you the summary. Let me close my camera and share my screen. But before I share my screen, I need to check something. Okay. Now I'm going to share my screen. I hope you can see it. Can you see what I'm doing, by the way, right now?
Yes, hocam.
Yes, hocam.
Let me go to the class page. And here, hydrology. Okay. Where is the project? Project is here. Okay, here there are basically three that are given to you. One is annual daily, the other one is hourly daily, and the other one is storage discharge. This storage discharge, you're going to use this one in the last step when you're going to flood routing. You don't need it in the beginning. And this one, let me show you. Okay, you're going to not this one. What? This one. This Beylerbeyi daily, annual daily max rainfall data. You are going to use this one to decide which distribution method is best for your data. Okay, you are going to import this data to HEC-SSP, and from HEC-SSP, you're going to decide which distribution method is best, and from again that software, you will apply it, and you'll get one value, which is called P100, because we are looking for 100 years return period for the rainfall. You'll decide what is P100, and you'll use that value in the upcoming parts of the project. And let me show you how to use this one. So you downloaded this data, right? As I said, I cannot import this data like this when these years are written like that because it gives a error. So I also mentioned this in my video as well. What I need to do is I need to go here. I need to change the format of my cells. This Excel is Turkish, by the way, but I think you can find what I'm doing in English very easily. It won't be a problem for international students as well. From this option, you will change the format of your cells in the Excel. You see, it's in general now. Genel means it's general. I need to find the date. So tarih means date. Okay, you'll select the first one. You'll say, okay. Then what you need to do is you'll go something like 1/1/ it was 1979, I guess. So I will go 1979. The last date, I mean, for here, 1/1/1980. But before I wrote this, of course, I also need to change the, oh, okay, it is changed. Then select these two and swipe it all the way to the down, and let's change it so they look good. Okay, what? I wrote it wrong. Yes. Okay, now it's better. Now I'm gonna save this onto my desktop so I can select it easily. Let me see if it is on the desktop. Where are you? Oh, oh. Here. Now I can close this one, and I'm gonna close this one as well for now. Now I'm opening HackSSP. By the way, your HackSSP should be version 2.2. Don't download the older versions. Download HackSSP 2.2. From here, okay, let me go slowly. From here, you'll come to the file and you'll say new study. You'll write the name of your study. Since I already use project or project one, I'll say project something like 10, that doesn't matter. You need to change your unit system from English to SI units if you're planning to use metric system. And what else? You can say okay. After that, you'll see the screen. From here, you need to select your data. How? You see this data file here. You'll come here, right click, and you'll say new. When you say new, you'll see a screen, something like this. We are going to import our data from Excel, okay? So you need to select this Microsoft Excel option. Don't forget to name your project 10 again. So I said Microsoft Excel. Now, from this row, it says Excel file, you can select your Excel project. Mine was on desktop and this weird name. I'll say open, and I can see the years and values. Even if these dates doesn't match, it doesn't matter, because for us, the only important part is this rainfall data, okay? This rainfall values. So you need to select only the data that you're going to use. So I'm selecting these. So you're not gonna cover the zero rainfall. You'll just select the values and you need to go.
Hocam, in
yes.
this part, last two cells weren't included, for example. In that way, if we add two cells in Excel, original Excel, we add the last two value actually.
What did you say? I couldn't understand. Can you ask
So the
again?
last value is actually 100, not 134. It's something like 68. So if we add 2 cell on the Excel, so that
Let me
in
check.
that situation.
Okay, okay. I understood your question now. Let me check. Let me check. Hmm. These 2 cells are missing, you're saying.
Yeah, if you add 43 and 44 cells, so in that time it shows actually the program.
Okay. I got your point. So let me reselect here and this one. How do you add? I never add before actually.
Hocam, in the Excel, for example, you just write something in 43 and 44 cell for both cell.
Okay.
Or,
So I should write here something random
yeah,
like this, but let me give you a number. Something like, so now it's gonna take it, you're saying?
yes, hocam, at least for me it works.
Okay, let me try. So I'm gonna close this one. If it works, that means you're a smart person. Yes, it works. See, weird solutions. Also, my solution to this error was a bit weird as well, but you know, since it's a new program to us, we are coming up with our solutions. So thank you for this heads up. So after we select everything, you can say import. Then here, once you said import, you need to write your units. Don't forget it as millimeter. You can change this name from flow to rainfall because we are investigating the rainfall. And then you need to say import study DSS file. But write the name again, project, let's say, import study. Now we need to check here if we can see the values, okay, when we say tabulate. And if you can see these values on the tabulate part, this rainfall values, that means you did it correctly and you can continue. Don't look at these dates. These dates actually doesn't matter. I asked even Berto, I said, Hocam, we have a problem, something like this. If he said, as long as these values are correct, what these dates are written in the program is not important. So once we get these values, we can continue. So we got this one. We imported our data onto this program. Now we need to check which distribution is best for us. For this, we're gonna come here, distribution fitting analysis. You'll say new, write the name, project 10, again, let's say. And from here, this data set, you select this one. And since we only imported one data, we have only one option. Okay, let's select. So you're seeing something like this. What do we need to do? We'll come to analysis, okay? We'll come to analysis and you will see from here which distribution method fits best, how you can do it. If you see these values here, that means the smallest value fits the best. But here there are some methods that we don't cover in this lecture, in this course. So you need to choose the best option that we covered in the lectures, okay? So for us, we can use this log normal method. So we don't know what is this. If, let's say, this was the best generalized Pareto, we don't know how to apply it. So you need to choose the best that you learned. How you can do these numbers should be the smallest. This Kolmogorov-Smirnov test. You can come here and read the smallest value, and you're going to use this one. Okay. So for us, it's log normal. So since we decided log normal is it's best for us from here, now what we can do is we'll go and we'll do the general frequency analysis. You can close this one. Okay. No. Now you'll come to general frequency analysis. You'll say nil. Again, write the project name, 10, and from the data set, select your data. Okay, here you need to make some arrangements. You need to select this analytical from this distribution option. You need to select this. These are also given in Bartoja's HackSSP video. You can also check from there as well. You're gonna select this one, the first one from the plotting position. I mean, it can be second one as well, but it doesn't matter that much. What else? This is important. Here you see something like log transform. If your solution, your distribution method is log, some log related method, you need to select use log transform. If not, you need to say do not use log transform. And for us, for our data, we said the log method was the best fitting distribution method. So we need to say use log transform method. From options, since we are looking for P100, what is P100? Means 1 over 100. So what is 1 over 100 is 0.01. And if you convert it into percentage, it will be 1%. So we need this one, we need to see this 1% here, okay? If you're seeing this 1% here in this frequency in percent, that means okay. So from the analytical part, and you need to use values from tables. From the analytical part, you'll come to this distribution and you'll select log normal, since we are using log normal. And what else? Yes, I think we are ready to compute our P100. So you'll say compute. Okay, it says analytical compute complete. Then you'll say view report. From here, you'll go down, okay, to see for 1% what is the rainfall. Okay, this is how we do it. So for 1%, our P100 will be 202.117 millimeters. If we were looking for, let's say, not P100, but something else, let's say if we were looking for 0.5%, we were going to take this value. But since we are interested with 100 years rainfall, we're looking for P100, and the value we are going to use will be this one, 202.117. Okay, this is how you get your P100 from the HackSSP. And once you get this value, actually you are done with HackSSP. The next steps are only about the Excel. Let me show you how to proceed in Excel as well. Now we can close this one, and that's, I think it was this one. Okay. In this example, the P100 was 223, you'll write here what is your P100. If it is 202, you'll write 202, whatever the result is. Actually, let me download this one so you'll understand better. Yeah. This is what is given to you originally. Okay, you have time, you have average, and you have cumulative. These percentages are the percentage of P100. So what that means, in between 0 and 1 hour, you have 17% of rainfall for that P100 value. So you need to basically multiply 17.15% with your P100 value. And I did it here, and I can show it to you. So the average is going like this, okay? These are given to you. These are given to you in the project tab. You'll see this, and you will turn it into something like this. How you can do it? You will multiply this 7.5% with your P100 value for this 0 and 1, between 0 and 1 hours, and you'll get something like this. If you look at the formulation, what I did, I'm taking this value, this D9, and multiplying with my P100 value and dividing it by 100 because this is 17.5%. Okay, so I'm basically doing this times 17.5 divided by 100, and you are doing this for all the time, for all the hours, like because you have 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, it goes like this. And then these are your intensities, because this average is given for intensity. To calculate your excess rainfall, you need to find your infiltration rates for these same time gaps. Then you will subtract your infiltration rates from your intensities, and then you will get the excess rainfall. So how will we calculate these infiltration rates? If you remember, you need to use Horton method. This one was the Horton equation, Horton infiltration equation. What it is? FF plus F0 times, sorry. Oh, by the way, we are running out of time. I will send another email, another Zoom link, then you'll join again after this one expires. So what do we have for Horton infiltration? We have FF plus F0 minus FF times e to the minus KT. So you need to find K value, F0 value, and FF value so that you can apply this equation. How you are going to find those values? You will find them by using your lecture notes, actually. From here, I think it was in Basin. Yes. Let me try Basin too. Because you have a given a soil type, and for a certain soil type, F0 and FF values are given, decided in these lecture notes, and you're going to use those values. They should be somewhere here. They're here. So as far as I remember, our soil type was one of those: clay loam, silty clay loam, sandy clay, silty clay, or clay. So your F0, but be careful, these are in terms of inch per hour, not millimeters. You'll get them and you'll convert them into millimeters. Okay, so our F0 is 3.0 inches per hour. For NRFF will be 0.1 inch per hour, and RK value, which is constant actually for all type of soils, will be 2. Okay, so once you find these values, I actually directly wrote them as in terms of millimeter per hours. You will convert them. You can actually use online converter. You can calculate it very easily. Then, as I wrote here, you'll write them here. Then for, let's say, for when t is equal to 0, you're going to use this equation, because right now we know what is FF, we know what is F0, we know what is FF, we know what is E. E is a number, like E is something like number pi. What is number pi? Is 3.14, and it goes like that. So for E, it's 2.718. You can use this value for E, and you know K is 2, and the only parameter is changing is the time. So for t, when t is equal to 0, you put 0 for t. When t is 1, you put 1. When t is 2, you put 2. And you'll do it for all of them. You'll calculate all the f values for certain time, like when t is 0, when t is 1, when t is 2. At the end, you'll calculate these, but we need f values for time gaps. Like we don't need this f value for exactly when the time is equal to 0. We need f value for these 0 and 1 time gap. And so basically you need to find the average. In this project, we want you to do, normally you need to calculate by integrals. You need to do integration, but in this project, to make it easier, we said you can take the average and you can use in that way. So what you need to do is, for, let's say for time gap 0, 1 hours, you get this 76.20, and for t is equal to 1, you'll get 12.51. You'll sum them and you'll divide by 2, like I did here. So you'll do it for all the time gaps. Okay, you will get those values. But as I said, now for these time gaps, we have intensities. We calculated them here, and we calculated this infiltration capacities. How you can calculate the excess rainfall runoff? You will basically subtract this infiltration capacities from your intensities. If you get something minus, just write 0. Okay, because you cannot have -3 excess rainfall. You need to write 0 if you get something negative. Okay, if it is not 0, you can keep it, but don't forget you are finding these in terms of millimeter per hour if you follow the steps that I did. So you need to convert them into centimeter per hour. So basically you're going to divide them by 10 and you'll get these values. For the next step, let me create another Zoom account. Okay, Zoom link. I'll send it to you and as an email, and we can continue from there, because the time is about to run out. We have only 4 minutes left. I don't want it to end in the middle of something. Okay. I'm gonna stop sharing now. I'm gonna send you the new Zoom links. Okay, then we can continue from there.